Hi everyone, welcome back to the Java class. So let us continue the concept of multithreading in Java programming language. So in order to understand the multithreaded application, let us create a class counter. Inside it, I'm just adding a variable of string type, the thread name, which will store the name of a thread. Let me just add a constructor over here in order to set the name of a thread using a thread name field. So here we go. Let us remove the super. It is not required. So this is a constructor. Let me add a method that is public void. And here the method name is count thread. Inside it, we can provide some body. So I'm just adding a for loop to iterate for a certain number of time. So here I is equal 0, I less than 5. Or inside it, let me just add a statement that will display the name of a thread plus iteration number that is present inside a variable I here, right? So this is a method that will display thread name iteration number 0, 1, 2, 3. So let us come to the main class, or inside it, let us create an object of a counter. Counter C1 is equal new counter, or inside it you can pass the name of a thread like a thread 1. So we are creating an instance of a counter in order to just iterate the body of a count thread function. So C1 dot count thread function you can call, and you can predict the output of this program. Let us see what is the output of this program. So here it will show thread 1 iteration 0 to 4 will print. So let us create one more thread, one more instance of a counter class. So that is counter C2 is equal new counter, and just you rename the name of a thread is 2, and you can call C2 dot count thread. In order to provide some separator between these two statements, so you can add some separator and you can see the output in something in beautiful way. And you can see both instance, that is C1 and C2, are executing the body of a count thread function in a sequence. So here we go, you can see the output, the thread 1 iteration 0 to 4, then some separator will come, then thread 2 iteration 0 to 4 will execute completely. So both instance of a counter class executing the body of a count thread function in a sequence. So if you would like to delay the iteration over some set of time, you can just add a sleep method. So let me just add a sleep method inside a count thread function, thread dot sleep. So inside it, you can add some sleeping time, or you can pause a iteration. So 500 is the time in the millisecond, or we can say pause an iteration for half a second, right? Half a second. So the sleep method always throw an exception. So you can fix this exception by adding a throws declaration, or you can surround with try and catch. So let me just add throws declaration here. So it throws interrupted exceptions. So now compiler is not complaining. Let us run this program, and what is the output? Now you will see first in the main class right now, because this count thread is throwing some exception of a type interrupted exception. So whenever you will call this function from the main thread, you have to fix this error from here also. So you can fix by adding a throws declaration in the main method. So it is fixed now. Let us run this program and you will see what is the output of it. So just let me show you the complete output. Let us save this program, right click on it, and you will see what is the output of it. So here you can see there is a small delay between each and every iterations, and you can see the output is in a sequence. The first instance of a counter class will complete its execution, then counter, then thread 2 means the second instance of a counter class will starts its execution, and so on. If you will create the multiple instance of a counter class and you will try to execute the body of a count thread function. So these instance will execute the body of a count thread function in a sequence. First, thread 1 will complete, then thread 2 will complete, then thread 3 will complete, and so on. So all the threads are completing its execution in a sequence, and then next instance will start. So let us understand how much time is required to execute the method count thread by all the instance like C1 and C2. So you can count the time using a system class, system dot current time in milliseconds. So here you can record the time before starting a thread. So it will return into a variable of long. So I can record in a start time is equal system dot current time in milliseconds. So when your instance body will be started, you are just calculating the time here. In the similar way, you can calculate the time after C2 dot count thread, or you can just rename it n time is equal system dot current time in milliseconds, or you can calculate the total time required to execute the count thread by the instance of counter C1 and C2. So you can display the total time required, right? Total time required, you can just write n time minus the start time. So you will get the how much time is required in order to process the count thread function by C1 and C2. Let us run this program and you will see what is the output of it. So here we go, you can see what is the output. Both threads are executing and it is calculating the total time. So total time required is 5072. So 5072 time is total required in order to execute the count thread methods, and we have added a small delay inside the count thread. So guys, so far we have not created a multi-threaded application. If you have observed the output of these programs, whenever you will run these programs, you can see the both instances are executing in a sequence. First, the thread 1 will complete its all iterations in a sequence, then thread 2 will complete all its iterations in a sequence, and it is calculating the total time required for these applications, right? So you can understand the power of multi-threadings and how will you see the multi-threading. So far we have not created any multi-threaded applications. So this is a kind of a single-threaded applications. All threads are executing in a sequence. In the next class or in the next session, I will show you how will you convert this program into a multi-threaded applications, or how will you create the multi-threaded programs, and you can just observe how much time is required to execute multiple threads simultaneously. So please just note down this time is right now to execute the two instance or the two threads in a sequence. Total time is required 5041. Now in the next session, I will show you how will you create a multi-threaded applications, and you can understand how much time you can save in order to execute multiple threads simultaneously. So guys, this is not a multi-threaded applications. I will tell you in the next session how will you convert this program into a multi-threaded programs. So guys, thank you for watching. Have a great day. Bye-bye. We'll see you later.